I mean, if you did any economic study with an 8% correlation between two variables, you pretty much say, you know, it's obvious that those two variables are not related. These were the same set of students. And then we went to final exam. The correlation between the first and third was back up to 60. Even though you expected decline in correlation, because final is a cumulative final exam. So that's, and not all students, some students need an 95 to get the grade they want. Some students need a 30 to get the grade they want. By that time, anyway, that was a natural experiment. Unknowingly, I saw that the exam results from unproctored online exams mean nothing. Why? Because it became a contest about who's better in looking up answers. If that was the goal of the course, sure, why not? Obviously, that's not the goal. But in real life, there are no natural experiments like that. For example, if sales and costs are 10% below what I thought they would be, more than likely, I couldn't sell enough of the new stuff. More than likely, some of my existing customers didn't switch. So that may be associated with lower level of decline in the sales of the existing products. For example, let's do this. If I did this first year decline of the old 50, let's see the effect of that. You know, that would actually increase my MPV by 11, right? Going from, 60 to 50. Or if I do them together, I mean, I still do get a negative number, but it's not as bad as it was before. And basically, the story, the lesson from that story is a lot of these input variables are correlated, statistically speaking. You know, for example, if I'm not getting very high first year sales of the new product, well, more than likely, I'm not getting too much on the growth either. How about let's do this 4 or 3, but the old stuff is not declining that fast either. So there are kind of scenarios. Okay. There is one thing we can do with the sensitivity analysis. Let's bring everything back to what they were. And let me check. Yes. One of the things you can do while doing sensitivity analysis is to ask the question, given that I have a risk on this variable, what is a break-even level for this variable? So I can ask, everything else being the same, which value of first year sales of the new product is going to give me negative 0 NPV. You know how we solve those problems. I'm going to go to my sheet that calculates the NPV, and I'm going to say, let's move this a little bit. Data, what if analysis, goal seek, make my NPV 0 by changing what I want to change, which is the first year sales. Of course, once you calculated the sensitivity to $1 change, you could have backed it up yourself too. But you know, this is not too bad either. So let's find out where our break-even level is. 88 and some change. Or I can go back to 90. What is the break-even level of first year decline of alt sales? That's going to give me 0 MPV. Turns out it's about 64. You can even do multiple variable break-even analysis, but there won't be unique solutions on those. But again, at the level of this class, I'm not going to get into it because you're going to have to then use something called solver. I will use that when we look at the return on risk analysis for stock returns, but not right now. And let's get back to the original. Now, if sensitivity analysis is limited in its usefulness, is there any other kind of analysis that I could do? Yes, there is. This is called scenario analysis. We already have a base case scenario. The base values of all of the inputs. For each of the inputs, you deem to be subject to forecasting risk. Determine a bracket around the base case value. For example, if I'm going to look at sales of the new product, maybe plus or minus 10% around that. Okay. Again, that's going to depend upon what you want to call how variable your forecasts are. To calculate a best case scenario, for each variable that affects MPV positively, which means if you increase that variable's value, it would increase MPV. Things like sales of the new product, growth of the new product sales. Choose the upper bound of the brackets. And for each variable that affects MPV negatively, choose the lower bound of the bracket. Costs are an example of this. If for example, annual fixed costs go up or variable cost percentage of the new sales goes up, my MPV is going to go down, right? Make sure we do this. That's not what I want to do. And for the worst case scenario, for variables that affect the MPV positively, use the lower bounds. And for the variables that affect the MPV negatively, choose the upper bound of the bracket. So let's do an example of this. Suppose the following are potentially risky inputs. Sales of first year sales of new products equals base value plus minus 10%. So if base value is 90, I'm going to do plus or minus 9 million, right? Percentage first year decline of existing base value plus or minus 5%.